So thanks everyone for coming. I know it's the last session before I'm between you and drinks. This is a dangerous place to be, but we're going to see how we can go today. So thanks for coming along. And what we're going to talk about is governance, and cloud governance in particular. Now, when I'm talking about governance, what I actually like to do is just start by thinking about government. What do you want from a government, and what would that mean in our cloud environment? So generally, most people, what they want from government is three things, really. They want to be protected from both internal and external actors. They want services that make their life better. And they want the freedom to live their life and do the things they need to do. Now, we think the cloud is basically exactly the same. Your application teams need the freedom to be able to use those capabilities and the agility of the cloud. But you have to wrap them in guardrails and protections to keep them safe, right? Safe from each other and safe from the outside world. And then they need a whole range of services to help us move faster, more accurately, and more securely through that environment. Now, the cloud changes really a number of our governance requirements compared to when we were internal. The first one is it's just moving so fast. 1,000 new features a year, new services and capabilities coming out all the time. This isn't your old data center anymore. And so when we think about governance, we have to be ready for that. We have to think about it in a new and different way that's able to handle that speed. Second, application teams now have the power. Used to be infrastructure teams had the power because they held the budget. And they could build large services and say, it's not ready yet, or you have to use my thing. That doesn't work anymore. Application teams choose when servers are deployed. They choose which services to use. They deploy on demand. They turn off on demand. They're in control of the infrastructure now. And from a governance point of view, we have to be ready for that, because that means we can't be proactive in our reviews or doing these things, because that means we're in the way and slowing them down. What we need instead is to work out how we're going to be real time to keep up with the pace of those application teams and move with them. Now, while all that action and excitement's going on, we also have higher expectations than ever before. I mean, when you're at a show like this, it's kind of like, oh my God, you didn't turn on flow logs? What are you thinking, right? Or, guard duty, you haven't used that and got your findings yet? You're not encrypting everything? Again, can you imagine in our old days of the data center if everything wasn't encrypted? That was just kind of normal and expected, even though we kind of wanted it to be. But now you have to do those things. If you're not, you're missing the mark. And by the way, those things are moving forward at 1,000 features a year. Those expectations are so high. And in addition, if you get it wrong, you probably will end up in the news. So we have to now think about that control framework and how we're going to be real-time, accurate with it at that scale and breadth. Now at Turbot, what we believe is that means that we're really changing now to a world of software-defined operations. We've had custom data centers, custom infrastructure, and we've gradually standardized that into the cloud providers and AWS. We still also, though, had all these custom processes and custom controls and custom ability to get things in our data center, wrapping that custom data center. We have to rethink that for the cloud. That software-defined infrastructure needs software-defined operations. Nothing else will keep up with the speed, consistency, size, and scale of it. It has become a software problem. It's not a scripting problem. It's not a process problem. It's not a reviewing problem. It's a software problem. And we have to start to think about and accept it in those terms so we can really prepare for that future. While we're doing all that, we need these services to speed people up. So we have to start thinking about how we're going to automate all of this. And you can't automate it if you're not clear on what it is. Working in a large enterprise, one of the things we went through as we were trying to move to cloud was, okay, you can go to cloud, but it has to do everything we do now. And then you ask the question, what do you do now? After you've spoken to about 80 people and worked out that Joe in such and such department names the subnets and someone else chose the AMI, it started to unravel all the processes and procedures, you realize that that's almost an impossible thing to replicate unless you actually use the same process. And that process takes 6 weeks. So the old 10-minute server really ain't going to function in that environment. To be able to automate that, you have to think about the whole. If you're going to launch a server in 10 minutes, what do you need from a security, compliance, and architecture perspective? You need to understand your networking. You need to know where you're going to land it, what subnets are going in. Does everybody agree that's a valid network? Does that network have reachability? Once we're in there, what security groups is it going to use? Who designed those? What ports can it have? Is this a Java application? Does it have application ports open? Security groups need to be there. What AMI am I running? Is it currently approved? Is it old? Is it patched? What size is it allowed to be? Right? And even after I get in there, we might want to tag it for cost reasons, etc. But I've got to get into that AMI and log into it. If I don't have authorized access in that 10 minutes, I didn't have a 10-minute server. I had a 10-minute server with a 3-day wait for authorization. Right? So what I need is to think about that 10-minute server. To me, that's actually the ultimate challenge when you're going to cloud to start. I mean, we all want to do serverless. They're cool things. But if you're sitting with a CIO, I think the challenge to say is, I want your support to get to a 10-minute server. Because to get to that server, we have to solve so many questions about operations, network, monitoring, security, approval processes, those things. That wraps up the whole thing in one question. That's measurable. You could show that in a meeting, right? So you've got to think about the whole as you do that architecture and the automation of it, because it's very, very repeatable. The other change that happens is that application teams actually start asking for help. When we're in a data center and we had budget differences, what happened was we ended up with I need a server. Well, you've got to put in a request. And then I want to track that request. So then I get a project manager, and then you need a project manager to fight with my project manager, or we're really going to be out of control. So now we've got project managers at 10 paces trying to get this stuff deployed. That completely changes, because once you go to the cloud with a model of self-service, you're no longer asking, give me a server, is it ready yet? You're now saying, can I launch a server? How do I do that? Please help me do this. So if we get our processes, procedures, security controls right, we can stay in that world of self-service, stay in the world where we're helping people be successful, and stay out of the world where we're responsible for every request, we're the bottleneck for every approval. But to do that, we have to think about our architecture and our automation end to end. So for us, what that comes down to is a number of key principles you have to meet in the cloud to get this working. The first one is you have to understand your rules and regulations for how you want to operate. You can start with standards like CIS, NIST, and other things. They're a great place to start. But actually, you have quite literally hundreds and thousands of questions to answer, which is an awful thing to say, but it's true. What's the name for every server? What's its host name? What IP addresses are we using? How do we name Lambda functions? What's our tagging strategy? Are we allowed to do those? How do you feel about cross-account access to Lambda aliases? Which, by the way, is separate from the versions and separate from the functions. You have to answer each of these questions so you can build that automation framework out and stay in control, while it's moving at 1,000 features a year. And what we find is, in actual fact, you might make those decisions, and then, of course, everything's an exception. Right? Every project has one thing they need different. So you can't think in terms of what's my control policy at the top. That just won't work. Once you have 1,000 accounts and all these different servers and buckets, you need to set rules like S3 must be encrypted, except for this one bucket, or except for this one account. So you have to think in terms of policies and exceptions. And you're going to have a lot of them. You might start with 10 Lambda functions. You're going to end up with hundreds of policies in a software package running. The next thing we have to do is think about our infrastructure. And that's really these services we're providing, how we're laying out and making sure we're always turning things on the right way. We want to make sure we always have guard duty, for example, or flow logs turned on, that we've always got CloudTrail on, laying out that common architecture and moving it forward consistently across those accounts. As we move to cloud, of course, we're moving to that help model. And that means now it's way more about collaborating and educating our users and working with them. Now that involves, for us, two models. One is first your juniors. You want to give them a lot of freedom to use it, but also keep them safe. Let's just fix things so they can learn by watching. And our seniors, we want them to be able to move forward without having to do all of that grunt work. So let's make them more productive and our juniors more safe. The way you achieve that is with real-time guardrails and automatic remediation. When someone creates an S3 bucket, within seconds, it should have encryption on, the tags should be right, version should be on, whatever you've chosen your posture to be. If you're playing whack-a-mole on tickets, you're going to spend the rest of your life chasing people and asking them to do things that they don't care about, but you do. If you automate these capabilities out, it changes the equation. Because what happens? I created a bucket and it was public, and you won't let me do that, and that's blocking me. It's like, yeah, that's blocking you. Come and ask for an exception, right? We can have a conversation about why you're doing that. True story, I heard that one time. It's so I can store the keys for the external CI server, right? That's the type of silly conversations you end up in, right? But what you want to do instead is start saying, no, yeah, it's blocked, but we can talk about it and giving you an exception. We can discuss how this service should work together, right? By moving that conversation to the start through automatic remediation, you have a good chance for success. Traditionally, we're sitting at the end, right? And we're stuck in that, I have to go live, my deadline's tomorrow, business unit needs it, and you're blocking me because you won't let this happen, right? By flipping it around, it changes the conversation. Once we have those pieces in place, we can give our teams that freedom. The freedom to create things, the freedom to work, because we can trust that it's in control. If we don't trust it's in control, we have to review everything before it happens or after it happens. We're constantly fighting that battle. Once we know we have a policy posture that's being enforced, we can move forward with way more speed and flexibility and consistency. So what I thought I'd do is show you a little bit how Turbot works to try and achieve that. So Turbot runs a software that basically allows each user to see the Amazon accounts they happen to have access to log into. We have a whole identity model for choosing that, which I'll talk a bit more about. But generally what you want is you want your users going straight into the console or the APIs or Terraform or CloudFormation. You want to give them that freedom. Don't force them into a pipeline. Don't abstract them into something that they can't use. Let them have that flexibility. Encourage them to do other things like pipelines. Don't force them there. Once they're in there, we just want to do something simple like creating a bucket. It's always a good sign when your demo bucket's called 13. Right, so we're going to create a bucket and let that go. What's going to happen now, though, fingers crossed, is in the next 10 to 20 seconds, Turbot's going to detect that new bucket. It's going to record it in the CMDB along with who made the change. It's going to find all the problems with it and then automatically fix those. So we're looking for that automatic remediation and fixing of that bucket in that real time. Let's check it out. So we come in here, we can see the versioning's already been enabled. We can see the default encryption's been turned on. We can see the tags have been set. I didn't have to do anything, all that happened magically around me, so now my bucket's compliant. If I go back to the Turbot console, I'll just do a refresh, it's not in the activity list yet. We can see our new buckets appeared there in our activity list created by me, and we can go in and see the detail. Turbot has recorded the full CMDB information here, including every detail of that bucket. That establishes a baseline, and now changes will be tracked with differences. Below that, we can see the full activity for this one bucket. So if we go down, we'll see when I created it. Turbot came along, established the policies and controls. And then we can see that certain things went into alarm and eventually got fixed here and then resolved to OK. So we have 5-second ticket close on those items. It's really good for your metrics, right, if you play that way. Now, what's fun here is we've also pulled out things like tags and made them a top-level citizen. This is very helpful when you want to start going cross-provider, cross-platform. We can see we have one control, the approved one, that's in alarm. We can go in here for detail on why. It's unapproved, and why? Because it's in an unapproved region. Now, when you have controls, the big thing to decide is what's the policy posture for how we made that decision, right? We don't want to say it's always unapproved because we need exceptions and stuff like that. So in Turbot, the way that we do that is with policies. So over here on the right, I can see policies like is it approved, and then something like the region. A lot of these are very simple. So this one here is it checked that it's approved. It's just in that checking mode. Others have more flexibility. For example, the regions one is a simple YAML list of these of wildcards. Now here we can see the policy is actually set higher up on a folder. So this is applying to every bucket in every account now and in the future. It's not one-off. We didn't have to say, I want this bucket this time done this way. This is a posture we've taken as an organization. But we can now create an exception for that if we have permission and say, actually, you know what? I'm OK for this bucket to happen to live in EUS1. And we'll just save that straight away. By creating that exception, we're now saying this bucket's OK to live in a different region to the others. But we've also created visibility to the differences in our environment. So if we go up, we can actually see in Turbot a list of all the exceptions to this rule. So as a security team, you're kind of like, hey, I've set this rule. I've granted these exceptions. You can see them all in that environment for that control. So that one now has gone to approved because it's now in a valid region given that policy structure. Most of the time, your policies and exceptions are pretty simple like that, but sometimes you want to go a little bit crazy. I want tags and I want prefixes of the bucket name and it's Thursday or whatever it is to say you should have an exception for that rule. So in Turbot, what we do is we support the idea of calculated policies. Now, the power of this is actually that we can query our CMDB in real time for information about the resource that's being protected. So that's a GraphQL query that has now found all the information about the tags and stuff for that particular bucket. If we combine that with some templating, I'm just going to grab a little snippet here. This is Ginger code for those who like Python. So this is a Ginger template saying, let's always allow US, but if the tag of the department is sales, then they're allowed to create buckets in Europe, right? If that tag is set in that way. And we can see that the policy is evaluated to the YAML and eventually come down to a list, and when we can set that policy. Now, what's cool about that is we can do things like, for example, say this is a valid policy for the next 90 days, and then your exception's over, and it'll automatically revoke, right? But when we save that policy, what happens now in Turbot is it goes off and calculates that policy for every bucket in that scope. It's determining the policy value based on the context of the resource it's protecting, right? This is wildly powerful and flexible. You can't even begin to imagine what's possible as you really get into it. Fingers crossed it's going to calculate in a second. There we go. So it's kind of calculated that. It's set that to the regions. That bucket's still approved because of that calculation. Now, if we come back to that resource here, we can see a couple of things. I'm sorry, wrong place. My bad. So this bucket here, let's go and browse it. Now, what Turbot does is it finds these things into the CMDB. It actually arranges them all into a hierarchy, which is what we use for the policy engine structure, right? So that hierarchy says this bucket actually has these controls on it. We can see which ones are green, which ones are skipped, etc. But now we can start moving up the stack. Before I do that, notice how we have very standard names for controls? Is this bucket active, as in, was it last modified recently? Has it been used recently? You might want to have a sandbox and just delete resources if they're older than 60 days. You can do that, right? Stuff like versioning, turning on versioning, tagging, standardize, default encryption. Is this bucket approved to exist? These are standard categories of controls for us, standard language we've learned and built over time. Because once you start doing this for 120 services with 5 resource types each, it gets pretty confusing if you've hand-built all of that stuff. So that standardization flows up. We have buckets arranged into regions. We can see the status of our controls for the region. We can go up to the account level and it's still calculating the status of all of our controls. Now, if I sort this by alerts instead, we'll see that actually the area where the most things in alarm is CIS. So now we can start drilling down into our CIS report for this one account. We could do it across all the accounts, across all the providers, it doesn't matter. But we can drill into this and see by area. Notice how it's all hierarchically arranged into these types so you can slice and dice in different ways. Now, if I come down, I can actually see the status here of, for example, the flow logs for this one VPC. And we get the full details of why and all that stuff. Our CIS controls run in real time. You create a VPC within 10 seconds, the status of that's in CIS report. Now, over here, we can actually start to compare or see how this stacks up. This VPC has a few errors. All our VPCs have a few errors, so this one's not much worse than them in general. Networking's roughly the same, but look at our categories here for this CIS report. You can see that they're all failing this right now. And so we can start to cross-cut from that and get into that. The bottom one to me is the most interesting. Most people know about CIS benchmarks, AWS CIS benchmark, there's other ones for other providers. Those CIS benchmarks actually map to CIS control framework put out by the Center for Internet Security across Linux and all those different things. So you can actually categorize these controls across. So Turbot supports all those categories for that reporting. So we can actually see now in a different environment, across the whole environment, what is the status of that one control. And then we can cut it by different things. For example, let's cut it by resource category. So we can see for this control, here's all the networking resources, wherever they may live, cut in that different way. Now, with that CMDB comes a lot of power. You can start to do searching for different things like our bucket we just created. But you can also search for things like tags. And that will find all the resources matching that tag. You can combine that with searches against native fields that are determined by the provider. So you can start to find any sets of resources here and query different pieces of information out of that CMDB. Governance, that was a bunch of examples of some cool governance. We have, by the way, 1,700 policies like that, so you can really kind of go insane trying to work through that and work out how to do it. But what we've found is actually that governance is a problem that exists not just in the cloud, but across the organization. Right? We need the ability to do governance of certificate expirations, DNS servers, all sorts of different things. So Turbot actually supports complete extensibility of that policy and control framework you just saw. You can write your own and have them appear in that UI with all the power of the inheritance, the calculations, etc. So one we just wrote a bit earlier was not that one, this one. So this is an expiration check on an SSL certificate that we whacked out. I'm just going to refresh this because it was pre my network change. So we have custom policies here to determine things like the expiration check or the warning period or stuff like that. These are policies. When you edit these, they have a nice enumerated list. Those are actually defined over in Turbot here in the policy definition. So these are JSON schema, tying that together. You can build those and then push them up to your server and deploy those policies. Then all your users are subject to that validation for those policy changes, the hierarchy of exceptions, etc., for whatever governance tasks you may have. That works in then the normal way like everything else we just saw. For example, if we set our expiration date here to instead of 90 to be like 365, we'll see the policy will control will rerun using that new policy value. And we should see a change in the status of the control in like 1 second. So Amazon's got 180 days or so to fix their certificate, right? They're in good shape, right? But that type of power of being able to build those sorts of governance controls in this sort of platform framework, that's what we're talking about when we talk about software-defined operations. We're not talking about a few bash scripts. We're not talking about a few Lambda functions. We're talking about consistent language at scale, supporting exceptions with a clear model for how to build it out and run it in real time, right? And that's sort of capability that Turbot provides. So when we think about what are the benefits of this type of governance, right, in our organization, the first is obviously speed. When you bring in this sort of software, you don't have to go and define all those things from scratch. The cloud team is massively enabled, right? Writing those functions from scratch, just like everybody else did, is not adding value to your business. For your development teams, they're moving faster because you can give them more freedom. The freedom to learn, the freedom to try, the freedom to do things. Second, our safety's gone way up because we're now in control of the environment and we're fixing it in real time. We've made it more accessible to our junior developers and more productive for our senior developers. And we actually have a model that will allow us to deal with the sheer pace, breadth, and depth of this cloud type of environment. So that's governance. Thanks for your time. I'm not standing between you and drinks, but if you have any questions, I'm happy to talk about it for as long as you'd like. Thank you.